Hey everyone, this is Dr. Walker. This is video 236. It's called Resistors in Series. I'd like to start off this video with a question. How is this possible? So you've probably dealt with Christmas lights and one bulb goes off and an entire strand goes off. But with your headlights on your car, if one goes off, the other one doesn't. So what's the difference? So put your thoughts in the comments below. And that will lead us to this video called Resistors in Series. When resistors are connected in series, it means that they're directly connected and there's no junction in between. This is very similar to the way capacitors were connected in series. There's only one wire connecting them. Another way to think about it is if you visualize the flow of charge from the positive terminal, if you visualize the flow of positive charge as the current going through, there's only one way for the current to flow through the circuit from one resistor to another. So definitely be able to identify resistors in series. So this is what a schematic diagram would look like. You have your battery in the bottom here and you have your two resistors. What we're going to be doing if we have more than one resistor is we're going to be simplifying them. So in this case we have two resistors in series. We want to find their equivalent resistance, Req, that has the same effect on the circuit as the original resistors. So how do we simplify our circuit from two resistors to one resistor? Let's take a look. We've got three different equations that are going to help us. So this is our circuit that has two resistors, and again we are simplifying it to one that has one equivalent resistor, Req. The first thing to know is that the potential differences or the voltages across each resistor add up to the battery voltage. We have our battery voltage right here. Let's say it's 9 volts. Let's say the negative terminal, the smaller line on the battery, is 0 volts and the bigger one is 9 volts. So we have a potential difference of 9 volts. So what we know is that the set of two resistors in series will get the entire 9 volts because all the points on the left wire here are at 9 volts. They're an equipotential surface. There's nothing else in the way, no way for the charges to lose energy as they travel through these ideal wires. And then on the right hand side, we know that all those points are at 0 volts. So there's a potential difference of 9 volts across the two resistors. So that means that the potential difference across each individual resistor, so delta V1 and delta V2, those two potential differences must add up to the full potential difference of the 9 volts. So if you simplify this circuit to one equivalent resistor, the 9 volts on the battery all of it would go to the equivalent resistor. So you can think as delta V as being the voltage across the equivalent resistor or the source in this case as well. The next one to know is that the same current goes through each resistor. So this is because they're connected in series. There's only one path for the current to flow. So the current through R1 is the same as the current through R2, is the same as the current leaving the battery and entering the battery, which is also the same current going through the equivalent resistor if you simplify the circuit to one equivalent resistor. And finally, the last property is that the resistances add up. So the equivalent resistance is more than any of the individual resistors. The best way to think about this is you see your two resistors here, just put them a little bit closer together. And then you can just imagine that your two resistors together are like a longer resistor, and a longer resistor has more resistance. So the resistances add up to get your equivalent resistance. So that's the equation that you're going to use when you're trying to find the equivalent resistance of two resistors in series. Let's look at an example. It's your turn just because it's a short example. So I do encourage you to pause the video and try it on your own. Assuming you've done that, let's take a look at this problem. We're looking at the battery current. So the current leaving the battery, which is the same as the current going through the resistors since they're connected in series. we know that there's a potential difference of 12 volts, delta V here, and we know there are two resistors. We know that the current depends on the voltage and the resistance. Ohm's law tells us that the current, I, is equal to the potential difference, delta V, over R, the resistance. So what we need to do is we need to simplify these two resistors into one circuit that has that equivalent resistor. So we can redraw it like this, where we have simplified our two resistors into R equivalents. Since they're connected in series, we know that the resistances add up. So the equivalent resistance would be 12 plus 6 ohms, which would be 18 ohms. So we know that the 12 volt from the battery, that all of it is going to the equivalent resistance. So we can use the equivalent resistance and the voltage to find the current through this circuit here, the simplified circuit, and that current is the same as the current through the original circuit because the resistors are in series. So all we need to do is plug in the 12 volts divided by the 18 ohms, and that's going to give us 2/3 amp when we simplify. So that's it for this video. The next video we will look at a different way to connect resistors, and that is to connect them in parallel.